Welcome dear learners. We are continuing Unit 5 Inorganic Chemistry Practical 1 Volumetric Analysis. In the present module we are discussing experiment 7, that is estimation of ferric ion. Contents of this module are aim of the experiment, principle behind the experiment, reagents required for the experiment, experimental procedure, that is preparation of standard more salt solution, standardization of potassium dichromate, estimation of ferric ion, and calculations and results of this experiment. First of all, aim of the experiment. This is the aim of the present experiment, that is to estimate the amount of ferric ion in the whole of the given solution of ferric alum, and approximately 0.1 normal solution of potassium dichromate and AR more salt crystals are provided. Principle of the present experiment. It should be noted that we are now performing the estimation of ferric ion, and this is a dichromate titration. You are familiar with the fact that potassium dichromate is a powerful oxidizing agent. It can oxidize ferrous sulfate to ferric sulfate. However, the given solution is a ferric ion solution. Then how is it possible to estimate the given ferric ion using the dichromate titration? For which you have to first reduce the given ferric ion solution to ferrous ion. Then again that ferrous ion is oxidized to ferric ion by utilizing potassium dichromate. So, this is very interesting principle and procedure behind this experiment. There is no direct reaction between potassium dichromate and ferric ion. So, you have to first reduce the ferric ion to ferrous ion and then oxidize that ferrous ion to ferric ion quantitatively, which make the estimation of ferric ion possible. We can now enter into the principle of the present experiment. A standard solution of more salt is prepared and potassium dichromate is standardized by titrating measured volume of the prepared more salt solution against potassium dichromate. This is the reaction responsible for the standardization of potassium dichromate. K2Cr2O7 plus 6FeSO4 plus 7H2SO4 gives K2SO4 plus Cr2SO4 thrice plus 3Fe2SO4 thrice plus 7H2O. Note the point, the ferrous sulfate shown here is from more salt. More salt is nothing but ferrous sulfate, ammonium sulfate, 6H2O. The equivalent weight of more salt is equal to 392, which is same as its molar mass. Now, the given ferric ion solution is made up to a known volume and ferric ion in a measured volume of the solution is reduced to ferrous ion by adding slight excess of stannous chloride. This is very important part of the experiment. Here we are quantitatively converting all the ferric ion present in a given volume of the solution to ferrous ion by using stannous chloride. Only ferrous ion can be oxidized by potassium dichromate to ferric ion. So, the given solution contains Fe3 plus ions. First of all, you have to reduce it to ferrous ion by using SnCl2 and then perform the oxidation with the potassium dichromate. The excess of stannous chloride is removed by using mercury chloride. Now, these are the equations responsible for the reduction of ferric ion present in the solution using SnCl2 and removal of SnCl2 by using HgCl2. 2FeCl3 plus SnCl2 produces 2FeCl2 plus SnCl4. SnCl2 plus 2HgCl2 produces SnCl4 plus Hg2Cl2. So, the first step is the reduction of ferric ion to ferrous ion or ferric chloride to ferrous chloride, and the second part is the removal of excess reducing agent SnCl2 by using mercury chloride. Now, the solution containing ferrous ion can be titrated against standard potassium dichromate using an internal redox indicator that is nothing but N-phenyl antranilic acid. So, the ferric ion present in the given solution is reduced to ferrous ion, and now the ferrous ion solution is titrated with the standardized potassium dichromate using the internal indicator N-phenyl antranilic acid. From the titer values, the mass of ferric ion in the whole of the given solution can be estimated. Remember, the equivalent mass of ferric ion is same as its atomic mass, that is equal to 55.85. Now, we are discussing the reagents required for the present experiment. These are the reagents required. Number 1, AR more salt crystals. The more salt crystals are required to prepare a standard solution with which we are standardizing the given potassium dichromate. And the second reagent is nothing but approximately n by 10 potassium dichromate solution. And the third reagent is of course the ferric alum solution, for which we are evaluating the presence of Fe3 plus ions, or we are use it for estimation. And dilute sulfuric acid, concentrated hydrochloric acid, stannous chloride, mercuric chloride, and N-phenyl antranilic acid, which is used as internal indicator. So, these are the list of reagents which is required for the estimation of ferric ion through dichrometric titrations. We are now entering into the experimental procedure behind the estimation of ferric ion through dichrometry method. The experiment consists of the following steps. The first step involves the preparation of a standard more salt solution. The second step being the standardization of potassium dichromate, for which we are performing a titration between potassium dichromate and standard solution of more salt. Last part is the estimation of ferric ion. This part comprised of reduction of the given ferric ion solution to ferrous ion solution and titration of that ferrous ion solution with the standardized potassium dichromate. So, we are now entering into the details of each and every step in a detailed procedure. First of all, preparation of standard more salt solution. Mass of more salt required to prepare 100 ml of n by 10 solution can be calculated as weight required equal to VEN divided by 1000. As you already know, V represents volume, E represents equivalent weight, and N represents normality. In the present case, you have to prepare a 0.1 normal solution of the more salt with the volume 100 ml. So, volume V is equal to 100 ml. Molar mass is same as equivalent mass. So, equivalent mass of more salt is equal to 392. Just multiply it with the 0.1, that is the normality of the required solution. Divided by 1000, you will get the mass required equal to 3.92 gram. Thus, on weighing out the 3.92 gram of more salt and prepared it into a 100 ml solution, you will get a concentration of 0.1 normal. Now, roughly weigh out 3.92 gram of more salt and transferred to a dry weighing bottle. It is then weighed by an electronic balance accurately, and the weight is recorded as W1. The substance, that is more salt, present in the weighing bottle is now transferred to a 100 ml standard flask through a funnel and make up to the mark by adding 10 ml dilute sulfuric acid and water. Remember, you must add 10 ml dilute sulfuric acid while making up the solution to 100 ml. This is because dilute sulfuric acid can prevent the hydrolysis. Now, the weight of empty weighing bottle, after transferring the substance, you will get an empty weighing bottle, and that empty weighing bottle should be weighed as W2. The actual weight of more salt can now be calculated as W1 minus W2. This weight, that is W1 minus W2, is used to find out the concentration of the more salt solution as normality of the more salt solution equal to weight per liter divided by equivalent weight. Now, the procedure behind the second step, that is standardization of potassium dichromate. We already prepared a standard solution of more salt and now we are performing the standardization of potassium dichromate. This is achieved by a titration between the standard solution of more salt with the given potassium dichromate solution. Here, a conventional titration procedure is adopted rather than a double burette method. Fill 1 burette with the potassium dichromate. 20 ml of the prepared more salt solution is pipetted out into a conical flask and add 50 ml dilute sulfuric acid and 10 drops of N-phenyl anthrandelic acid. You know the fact that N-phenyl anthrandelic acid acts as an internal indicator in this reaction. Now you are having a mixture of 20 ml more salt, 50 ml dilute sulfuric acid and 10 drops of or 0.5 ml of N-phenyl anthrandelic acid. Now titrate this mixture, this solution against potassium dichromate taken in the burette and end point is determined. Remember, the end point is the color change from green to violet red. That is the color change of the internal indicator N-phenyl anthrandelic acid. Now you have to repeat the titration for concordant values. We are now demonstrating the experimental part of the standardization of potassium dichromate. Over to experiment. Part of the potassium dichromate demonstration, and now entering into the calculation part. The weight of more salt taken is equal to W1 minus W2, which is equal to 3.942 gram. Now weight per liter of more salt or weight per liter of more salt solution is equal to 3.942 multiplied with the 10, that is equal to 39.42 gram. Normality of more salt solution can be calculated by using the expression weight per liter divided by equivalent weight. Weight per liter we got as 39.42 and you have to divide it with equivalent weight of more salt, that is equal to 392. You will get the normality of the prepared more salt solution as 0.1006 normal. Now, the titer values in the standardization procedure can be tabulated like this. This is the titration between standard solution of more salt with the potassium dichromate. Here you can see the volume of more salt pipetted out during 3 courses of titration, that is equal to 20 ml. From the burette reading, initial and final readings, you will get the volume of the potassium dichromate used, and you can see the concordant value, that is the volume of potassium dichromate used in the titration is equal to 20.2 ml. Now, from the titer values, we can calculate the normality of potassium dichromate solution using the relation N more salt into V more salt is equal to N K2Cr2O7 into V K2Cr2O7. N more salt is already calculated, which is equal to 0.1006 normal. Volume of more salt pipetted out is equal to 20 ml. And volume of potassium dichromate used is equal to the concordant value of the titration, that is equal to 20.2 ml. Now we got the normality of potassium dichromate equal to 0.0996 normal. This is the normality of the given potassium dichromate solution. By using this, we are now entering into the estimation of the solution. Now, last part of the experiment, that is estimation of ferric ion, we are now discussing the procedure. The given ferric ion solution is made up to 100 ml in a standard flask. 20 ml of this solution is pipetted out into a 250 ml beaker and provided with a cover wash glass. About 5 ml of pure concentrated hydrochloric acid is added and it is heated to boiling. Remember, by adopting this procedure, we are just reducing ferric ion present in the solution to ferrous ion. The procedure is continuing. To the hot solution, SnCl2 solution is added in drops till yellow color of the solution is just discharged. 1 drop more of SnCl2 is added and the solution is diluted a little. It is now cooled under tap and 4 ml cold solution of 10% HgCl2 is added rapidly and shaken well. 50 ml of dilute sulfuric acid and 10 drops of N-phenyl anthranoic acid indicator are added. It is then titrated against K2Cr2O7 taken in the burette and end point is determined. Remember, the end point of the titration is the color change from green to violet red. From the titer values, the amount of ferric ion in the whole of the given solution is calculated. Conduct a duplicate experiment. Now we are demonstrating the experimental part of the estimation of ferric ion. experiment and now entering into the calculation part. From the titer value, we can calculate the normality of the ferric ion solution using the relation N1 V1 equal to N2 V2. N1 is equal to the normality of the ferric salt solution. V1 is the volume of the ferric salt solution. N2 is already calculated, which is nothing but the normality of potassium dichromate, which is equal to 0.0996 normal. V2 is the volume of potassium dichromate used, which is the concordant value of the titration during estimation, that is equal to 20.4. And N1 can be calculated by using the expression N2 V2 divided by V1, that is equal to 0.0996 into 20.4 divided by 20, that is equal to 0.1016 normal. That is, you got the normality of the ferric ion solution, which is equal to 0.1016 normal. Now, weight per liter of ferric ion in the solution can be calculated by using the expression normality multiplied with equivalent weight. Normality we already calculated as 0.1016. Just multiply with equivalent weight of the ferric ion, that is equal to 55.85. You will get the weight per liter as 5.674 gram per liter. Now, mass of ferric ion in the whole of the given solution is obtained by dividing weight per liter with the ton, that is equal to 0.5674 gram. Now, we are consolidating the final results of the experiment as the normality of the given ferric salt solution equal to 0.1016 normal. Now, weight per liter of the ferric ion in the given solution is equal to 5.674 gram per liter, and finally, mass of ferric ion in the whole of the given solution is equal to 0.5674 gram. Thus, we have discussed the experiment of estimation of ferric ion using dichromate titrations. That's all about the present module. Have a nice learning experience. Thank you.